What if we told you that everything in this world is just a number? If world is just a number, this could mean all that happening to us are some complex mathematical equation that begin from one root to the end. This sign that everything we do is predetermined. This concept will be discussed in this video. Socraters Inc. present Our Mathematical Universe, the summary, from the author Max Tegmark. We will explore the intriguing idea that our entire universe has mathematical structure. This means that everything we experience and observe, from the small subatomic particles to the largest cosmic structure, can be described using mathematics. According to Tegmark, this idea is supported by a number of scientific discoveries, including the fact that the fundamental laws of physics can be expressed using mathematical equations. And the properties of the universe seems to be finely tuned to allow for the existence of life. But what does it mean for the universe to be a mathematical structure, and how does this idea fit with our everyday experience of the world? Soon, we will explore this question and delve into the fascinating implication of the idea that the universe is mathematical structure. But before we go to the first chapter, please give us a like and subscribe to our channel to connect with more people around the world. Chapter number 1. The Unreasonable Effectiveness of Mathematics. The effectiveness of mathematics in describing the world has been long a subject of fascinating and study. One of the main reasons that mathematics is so effective at describing the world is that it's precise and logical language that can be used to make precise predictions about the behavior of the universe. One possible explanation for the effectiveness of mathematics in describing the world is that the universe is inherently mathematical in nature. This means that the fundamental laws of the universe, such as law of physics, are simply a reflection of the underlying mathematical structure of the universe. This would explain why mathematics is able to make such accurate predictions about the behavior of the universe, as it would be based on the fundamental structure of the universe itself. Another possible explanation for effectiveness of mathematics in describing the world is that the universe was designed by some higher intelligence or the force to be mathematically elegant. This would mean that the universe was created in such a way that it follows mathematical principles, which will explain why mathematics is able to make such accurate predictions about the behavior of the universe. Despite the success of mathematics in describing the world, it is still not fully understood why it is so effective at doing so. Further research and study may help to shed light on the underlying reason for the effectiveness of mathematics in describing the world, and may help to deepen our understanding of the nature of the universe itself. Chapter 2. The Many-World Interpretation of Quantum Mechanics. The many-worlds interpretation of quantum mechanics is a controversial theory that suggests that the universe is constantly splitting into multiple parallel worlds, each corresponding to a different possible outcome of a quantum event. This theory was developed as a way to resolve the apparent contradiction of quantum mechanics, which is the theory that describes the behavior of subatomic particles. According to many-world interpretation, every time a quantum event occurs, the universe splits into multiple parallel worlds, each corresponding to different possible outcomes of the event. For example, if an electron is observed to be one of two possible states, the many-world interpretation suggests that the universe split into two separate worlds, one in which the electron is one state and one in which it is in the other. This means that every possible outcomes of every quantum event is realized in some parallel universe. The many-world interpretation has been supported by a number of scientific experiments, including the famous double-slit experiment. In this experiment, a beam of electron is passed through two slits and strikes a screen on the other side. According to classical physics, the electron should create two distinct patterns on the screen, corresponding to the two slits. However, when the experiment is performed, the electrons create a diffraction pattern on the screen, as if they had passed through both slits simultaneously. The many-world interpretation explains this strange behavior by suggesting that the universe splits into multiple parallel worlds, each corresponding to a different possible outcomes of the experiment. In one world, the electron pass through one slit and create a pattern on the screen. In another world, the electron pass through the other slit and create a different pattern on the screen too. The many-word interpretation suggests that these two patterns are both observed in separate parallel worlds, which explains why the diffraction pattern is observed in the real world. While the many-word interpretation is a controversial theory, it has gained support from many physicists and has been used to explain a number of other phenomena in quantum mechanics. However, it is still not widely accepted as a definitive explanation for the behavior of quantum systems, and further research and study will be needed to fully understand the implication of this theory. One of the main criticisms of the many-word interpretation is that it is so difficult to test and verify, as it suggests the existence of parallel worlds that are not directly accessible to us. Another criticism is that it is a highly speculative theory that goes beyond the current limits of scientific understanding. Despite this criticism, the many-word interpretation remains an important and intriguing idea that continues to be studied and debated by physicists and philosophers. Chapter 3: The Mathematical Universe Hypothesis. The mathematical universe hypothesis, proposed by Max Tegmark, is the idea that universe is not just described by mathematics, but is actually a mathematical structure. This means that everything in the universe, from the smallest subatomic particles to the largest cosmic structure, can be described using mathematics. According to Tegmark, this idea is supported by a number of scientific discoveries, including the fact that the fundamental law of physics can be expressed using mathematical equations, and that the properties of the universe seems to be finely tuned to allow for the existence of life. If the universe is mathematical structure, as proposed by the mathematical universe hypothesis, it has a number of interesting implications for our understanding of reality. One possibility is that the universe is a simulation, and that everything we experience is just an elaborate projection of some higher reality. This idea has been explored in popular culture, such as the movie The Matrix, and has been the subject of many philosophical debates. Chapter 4: Implication of the Mathematical Universe Hypothesis. If the universe is mathematical structure, as proposed by the mathematical universe hypothesis, what does this mean for our understanding of reality? One possibility is that the universe is a simulation, and that everything we experience is just an elaborate projection of some higher reality. Another implication of the mathematical universe hypothesis is that the universe may be infinite and contain an infinite number of parallel worlds, as suggested by the many-word interpretation of quantum mechanics. This would mean that everything that is possible will eventually be realized in some parallel world. The mathematical universe hypothesis also has implications for the concept of free will. If the universe is mathematical structure, then everything that happens is predetermined by the underlying structure. This could mean that free will is an illusion, and that our choice and action are simply a result of the mathematical structure of the universe. Chapter 5: The Role of Consciousness in the Mathematical Universe. One of the most intriguing aspects of the mathematical universe hypothesis is the role that consciousness plays in the structure of the universe. According to the Tegmark, consciousness may be a fundamental aspect of the universe and may play a role in the mathematical structure itself. This idea is supported by the fact that consciousness seems to be closely tied to the physical structure of the brain, and that certain mathematical structures have been shown to be associated with specific states of consciousness. If consciousness is a fundamental aspect of the universe, it raises the question of whether or not it is possible for consciousness to exist outside of the physical body, and whether or not it is possible for consciousness to be transferred to other mathematical structures, such as computer simulation or other parallel universe. And since brain transplant is still not possible to transfer consciousness, this means this theory still needs more exploration. Final key summary. In our mathematical universe, Max Tegmark explored the intriguing idea that the universe is a mathematical structure and delved into the fascinating implication of this idea. From the unreasonable effectiveness of mathematics in describing the world to the role of consciousness in the universe. This book offers a thought-provoking look at some of the most fundamental questions about reality and gives us a new insight and perspective on things. As hard as this information might be sound unfamiliar, I hope this video is quite informative for all of you. Please subscribe to our channel so we can make more content like this. If you have any question or would like more information, I recommend checking out the book for a more in-depth exploration of the concept discussed. Thanks for watching, Socraters.